All right, we showed you how to tear a rotary engine apart with Ken at our shop, and now we're here with Joe, my rotary guru. He takes me through the world of rotary engines. We're gonna build a Renesis engine. This is actually the engine that came out of my old RX-8, which Joe now owns. It's not going back into that car though, it's being sold to somebody who really wants to go fast in an RX-8, I guess.
Yep.
Something like that. All right, let's show you how to build one of these things. Super easy, I promise. All right, Joe, you got a whole table full of goodies here. Do you want to maybe give us a quick rundown of what you have and why you have it and what we're going to do with it?
Sure, yeah. So we've got the Renesis irons here from the Project RX-8. These were street ported using the Racing Beat street port templates quite a few years ago when we first built this motor.
Yeah.
And these were the original housings we used. These were actually resurfaced by Goopy Performance back then when we built it originally as well.
Yeah.
Again, these are as well the original apex seals that came out of this motor when we built it.
Yeah.
And the Racing Beat lightweight rotating assembly. These are the lightweight RX-8 rotors that we had acquired from Racing Beat. Yeah, this is basically the bare bones of your rotating assembly, the crankshaft or eccentric shaft, the counterweight, flywheel, rear counterweight, and this is all the new stuff. New rotor housings, well, good used rotor housings that we had resurfaced by Goopy as well, and new apex seals to go in our new fresh engine.
All right, so what's step one then to assemble this thing?
Well, I've done a lot of the prep work already in order to assemble these. So these rotors, you can tell, these are all gooped up with Vaseline.
Okay.
All of these, the side seals here, have been pre-clearanced to the corner seals, which are these round guys here. And the oil control rings, new oil control rings go in these scrapers. They've been all pre-assembled in the rotors. I've got everything done here. We just need to basically stack all this together and install the new apex seals in the rotors once they're all together, and we'll be ready to fire it up in no time.
All right, sounds easy, Joe.
Yeah.
All right, Joe, we've got a couple housings here. Do you want to give us a quick rundown of how these differ and what Goopy's done to this one?
Yeah. So this was the housing that came out of the engine that we had built years ago.
Yeah.
And this motor's seen a lot of track abuse, a lot of mileage.
A lot of high RPM abuse too.
A lot of high RPM abuse, yeah. So
I got my money's worth out of that thing.
yeah. So you can tell probably all the grooving and the chatter marks.
Yeah.
It's very obvious when you run your finger across it that it's.
And that's the apex seal, literally like kind of digging into this finish.
Exactly. Yeah. A few things cause that. Definitely high RPM will cause that.
Yeah.
Also lack of lubrication. I don't believe that the RX-8s are very known for injecting a lot of oil, so it could be the lack of oil lubrication that helped contributed to those chatter marks.
Yeah, and I wasn't pre-mixing or anything.
No,
so
exactly.
That may be part of it.
That it would have been helpful if we had pre-mixed the motor from day one. That probably would have reduced all this damage that's here.
Yeah.
And
when we threw the supercharger on it too, we had a lot of tuning issues. So
a lot of tuning issues.
That probably contributed.
Yeah, exactly. Detonation and all sorts of things. So
rather than trying to reuse these chattered up housings, we used the original motor out of my RX-8, which was just sitting in storage.
Yep, and we
sent these down to Goopy.
Took it apart, and these housings were in decent condition too, but obviously a used housing is going to have some wear marks and score marks and whatnot. So the best thing to do is to have them resurfaced, and then it gives you a perfect flat surface for the new apex seals to wear against.
Yeah. I should mention we are here at Mantella Autosport, which explains all the racing tires. I do mean all of them. Where Joe works as a full-time race technician. So this rotary stuff, he used to do full-time when you had your own shop called RPM, right?
Yep.
But
now it's just part-time for fun.
Now it's just the way it should be.
Yeah.
Rotaries should only be dealt with for fun. Only a crazy person would try to make a living off these things.
Yeah. So here is our Goopy offers a gasket set, reusable gasket set for these engines.
Okay.
So there's your coolant seals, outer coolant seals, and these are the inner coolant seals.
Okay.
And believe it or not, these are reusable. So if we were to put this motor together, assemble it, fire it up, run it for, say, a year, you could probably disassemble the motor, and if you had an issue with the motor, you could disassemble it and reassemble it with these same coolant seals.
Really, that's impressive. Step one, Joe dropped these dowel pins, or is that the right word for those, Joe?
Yes,
dowel pins?
Dowel pins, yeah.
Drop those in there on the bottom iron. And now it's kind of like building a sandwich. This is like the lower piece of bread, and we just keep stacking in all the goodies from here. It's a Brap sandwich, everyone.
So on the Renesis engines, the grooves for these coolant seals are actually in the aluminum rotor housing.
Okay.
Older engines from like the FD or the FCRX7, the grooves are actually cut into the irons.
Oh, really?
So these are a little bit different.
Interesting design change.
In my opinion, it's better. The older FD irons actually, from people not changing coolant, they get rotted and the iron actually breaks. So now your coolant seal falls into the, pushes out and falls into the coolant jacket. And now your engine starts using coolant and
bad things happen.
And bad things happen. And then basically the iron's useless at that point. Once it's broken, it could be repaired, but really the strength isn't there anymore. So
this is a design improvement on the Renesis, which is a rare thing to say. We don't otherwise like the motor all that much compared to the FD motors. I guess the biggest sort of design challenge with this Renesis motor is the way they designed the exhaust ports into the irons.
Yeah, exactly.
The older motors have the exhaust ports on the housings, which is what Joe's is working on now. And that seems to get the heat out of there better than out of the irons. And I guess all that trapped heat in the irons tends to warp side seals and...
Yeah, chews up the side seals, chews up the corner seals. It's just not an efficient way to get the heat and exhaust out of the engine. Yeah. So
I wonder why they did that. Was that a emissions thing maybe?
Probably emissions stuff, yeah. I don't know how that would improve the emissions, but...
Whenever we don't understand why they do something, we just blame it on emissions.
Okay. And I just...
So what is that seal for?
So that seal is for the upper dowel pin.
Okay.
There's actually one on either side, so there's a groove that sits in, and on the other side, I'll do that once the housing's down on the motor. But this upper dowel pin that goes through the whole motor from front to back, actually oil travels through that up to the front iron. Okay. So you need to be able to seal that.
Right.
And so we've got our coolant seals placed in there with the Vaseline, and I've actually just given the whole housing a little light coating. Just like assembly lube. Assembly lube, yeah.
Yep. Baby scented Vaseline, everybody. If you're building rotaries, go stock up. The cashier may look at you like you're a perv, but just grin. Give her the thumbs up, maybe a wink.
So we just give these little legs here a coat of RTV.
Okay.
Both sides, just up to the point where the water jacket starts.
So that's a water seal issue?
Yeah. The RTV stuff here is actually for oil. So if you could imagine this is your water coolant passes through these ports.
Yeah.
You've got your inner, that would be where your inner seal goes, and the outer seal. Now below here, in this void here, is actually your oil pan. Your oil pan sits on the bottom here. Mm-hmm. So you have a seal, an oil pan gasket or seal that would go along here. If you don't put any RTV on these legs, it's just metal on metal when you assemble the motor. So oil could easily seep past here out. So now you've got an oil leak.
We don't like oil leaks.
No oil leaks.
We're not Porsche owners.
Yeah, air-cooled life.
So one shot at this, let's get it right.
Let's do this.
As you can see, Joe's put in the other seal on that dowel pin, and now he's dropping in the coolant seals on the other side of the housing.
There There we go.
Ah.
Just got to give these a little bit of a stretch.
Oh yeah?
Just a bit. Just the outside one seems to be a little
Bit of a snug fit?
snugger fit, so the little stretch doesn't hurt.
It's all right. It's too bad Pete's not here. He's good at stretching things out. And these are both coolant seals.
Mm-hmm.
So there's coolant running through all of these passages
Yeah,
between those two seals.
that's what cools the motor. Oh, I'm fighting it.
Just need a little more stretching.
It's fighting me, yeah. Just a little bit more stretching.
Because the
next time.
camera's rolling, things always fight you when you're
Struggle.
in front of the camera.
The struggle is real.
Yeah.
There we go.
Okay.
Good. So I've got these already pre-marked. So number 2 is this tip here.
Okay.
Got it marked number 2. So I'm doing these, putting these in with the corner seal piece missing.
Okay.
But they're going to go into their groove, and we'll assemble those once it's in the.
So you put the corner seal in once it's actually in the housing.
In the housing, and the springs are below it. So.
Right.
So there.
So these apex seals are held against the mating surface in the housing with springs beneath them.
These springs right
These
here.
weird sort of like bow shaped.
Yeah, just look like a thin piece of welding wire almost.
Yeah, that pushes the seal up. Don't drop the seals, Joe.
Exactly. That's why the Vaseline
Oh, the Vaseline actually helps it kind of stick in?
holds all the seals in place while you drop it down.
Really?
And there we go.
Look at that. So that triangle or trochoid, I guess is the technical term? Sort of a bloated, or no, the trochoid's the shape of the housing,
Yeah,
isn't
the
it?
trochoid's this shape with the
Sort of oval shape of the
figure eight.
housing, yeah.
So I'm just gonna, of course, never use enough Vaseline, so all the bearing surfaces get a little coat, and we'll put the eccentric shaft in there to hold it. So here's the eccentric shaft. Slide it.
Which is the equivalent of the crankshaft on a piston engine.
Crankshaft, correct.
And I guess you could think of the rotors as kind of the equivalent of both the pistons and the camshafts, right?
Yes.
Because they both create compression within this combustion chamber. You can kind of see that there's 3 parts to the combustion chamber here. And the way the tip of those apex seals pass over the intake and exhaust ports determines your timing.
Exactly.
So that's kind of like your camshaft timing.
Exactly, yeah.
All right, that's your quick and dirty lesson on rotaries.
So we'll put the long spring in first.
So there's more than one spring that goes in there.
2 springs, yeah. So the long spring in first, and we'll shove it down until it bottoms out. And now.
So is that bottom out in the bottom of that apex seal groove?
Yes.
Okay.
So there's it's bottoming out on the bottom of the apex seal itself. On the base, there's actually a cutout for that to sit up against.
into? Oh, okay.
So, and then also in the middle of the apex seal, there's also the same cutout for the smaller spring. So the
Gotcha.
spring pushes from the.
And you can tell by feel that it's in place?
Oh, for sure, yeah. And this spring, once you push it down, you should hear it click. So,
Oh, yeah.
there, little click.
I heard it click, yeah.
So that spring is all intact.
Sweet. So do that 2 more times and we're ready to party on rotor number 1?
Mm-hmm.
All right, so Joe is fiddling with a little corner seal.
Okay, so the corner seal just sets down into place over top of the spring.
So there's a spring.
So that the end of that long spring that we first installed
Yeah.
actually sits on this face right here, and that little edge is to stop it from actually coming straight out of the end.
I got
So that's
ya.
your stopper. So there's a very similar stopper like that on the opposite side of the long piece of the apex seal.
Gotcha.
So that's where that sits.
So that actually seals and prevents the spring from coming out.
Mm-hmm.
It's a 2-for-1.
Mm-hmm.
We like that. All right, Joe's about to RTV up these bottom legs again. Same reason as before, I assume.
Yep. Yeah. Keep the oil in. No leaks.
You can see there's sort of a groove in the casting too, which I guess is just to hold the RTV in place.
Probably holds the RTV in place a bit, yeah. Gives it a bit more surface to stick to.
Yeah.
We'll go with that.
Sure, that's a good theory.
Yeah. I'm no engineer, so.
We're just winging it here, Joe.
Yeah. Yeah, we actually don't have a clue what we're doing.
How many rotaries have you built over the years?
Oh my goodness, I don't even have a clue. I started building motors when I was 14, and I'm 30 now, so.
16 years of rotary building.
Yeah.
So it's safe to say you've built 16 of these, if not
at least
50 or 60.
Yeah, probably. Here's the difficult part now. Getting this center iron over top of this eccentric shaft.
And it's difficult because there's that sort of step in the
There's
shaft.
that lobe in the shaft.
Lobe,
so
yeah.
what you got to do is actually lift this up with your knee.
Oh, nice. Look at the technique here, Internet. The gun show is in effect too.
Yeah.
Ladies, divert your eyes. Look at that. He's rotarying like a boss here.
Not quite all the way down yet.
Oh. It's all right.
Here we are.
Just like that, huh?
Just like that.
You made that look pretty easy.
I did. That went really smooth. They don't always go like that.
No.
No.
Cooperative
No,
irons.
sometimes when you're lifting that eccentric shaft, the rotor will move a little bit and those corner seals will pop out.
Yeah.
So
That was nice.
it worked well.
All right, it's a good omen. This motor is going to make jam. Makes me want to keep it now, Joe. Can I buy my RX-8 back?
I'll give you a good deal on it.
Only twice what you pay for it, right?
Yeah. All right. More coolant seals going in.
Everything getting lubed in Vaseline. Is this like a normal rotary engine builder thing to use Vaseline?
I think so. Any engine builder I've ever talked to or know, they all use Vaseline. Now whether it's baby scent or not, I don't know.
That's personal preference.
Yeah, that's up to the builder. But yeah, the Vaseline seems to work really well. Like we said previously, it works really well for holding these seals in. It's nice and it's sticky.
Yep.
And it also gives it like on these the rotor surface, it gives it that just protection so that the brand new seals aren't just totally
Metal on metal,
totally
yeah.
bone dry.
Yeah.
Metal on metal rubbing if you
Yeah.
crank the motor over. So.
And it's a petroleum-based product, so it'll burn off pretty quick.
Oh yeah. They smoke pretty good when you very first start them up.
Yeah.
But yeah, it burns away pretty quickly. Sometimes you may foul the plugs a bit in the first startup, but yeah, they burn away pretty quick.
A rotary that smokes and fouls the plugs. That's hard to believe, Joe.
They don't need Vaseline to do that. They do that on their own.
Just need to be turned on and off once or twice.
Exactly. Yeah. All right.
So this is obviously the same process we did on the other housing, just installing these coolant seals.
Coolant seals. Oh, look at that one. That one fit
Oh
perfectly.
man, the stretching technique was on point there.
That was spot on. Yeah.
On the money.
Okay, and our dowel pin O-ring here.
Yeah. More Vaseline, and now it's time for rotor housing number 2.
Second rotor housing. So we'll put the dowels down here first.
All right. Housing number 2 in place. So they call these a 2-rotor engine for reasons that are probably becoming obvious. 2 rotor housings, 2 rotors. Rotor number 2 is about to come in. Right, so same process as before, you're just sort of pre-assembling the apex seals.
Mm-hmm.
Dropping those in.
There we go.
And off we go.
Go.
Look at that. You can see the exhaust port down at the bottom here, and the intake port up at the top. So air comes into the top and the rotor spins and then it exhausts at the bottom.
So what you've got here is, you've actually got three things happening at once. So this port, this chamber right now is actually, if the motor was running, the air would be being sucked into this chamber.
Yep.
Over here, this is already compressing. You've got actually spark plug holes right here.
Yep.
So two spark plugs here. This is already partway through the compression. And this side is already exhausting because that exhaust port is open.
Right.
So the rotor has passed that. So
Yep.
like, all the explode fuel and air mixture is now exiting there.
Yeah.
And this is all happening all at the same time as this spins around. Intake, compression, exhaust.
And the rotor is spinning 3 times for every 1 spin of the E-shaft, or is it the other way around?
Other way around.
Other way around, right.
So
the rotor speed is a third of the E-shaft.
Yes.
For the
So
crank speed.
So your say your idle is 900 RPM, so your crankshaft is spinning 900 RPM. These rotors are actually only spinning 300.
Yeah. So even though you're revving this motor to 9,000 RPM, the rotors are only seeing 3,000 RPM.
Exactly.
Which is why they can rev so high reliably.
Yes.
We could put reliably in air quotes, I guess, but that's not because of engine speed, that's for sure. Apex springs and corner seals going in.
Corner seals going in, and then rear plate, and we sandwich the whole thing together.
And this whole process goes pretty quickly. I guess a lot of the real work goes on prepping everything prior to assembly, right?
Exactly, yeah. Clearancing all the seals, getting the right measurements. Yeah, like these side seals, I mean, there's 12 of them.
Yeah.
And each one can take, 15, 20 minutes, maybe half an hour, depending on how the process you use to clearance them.
And what is that process?
I use a stone grinder on a die grinder,
Yeah.
and I just very lightly will touch the end of this seal. They come very long, extra long from Mazda, and you clearance them yourself. So,
Okay.
So yeah, usually you set them in, see how much overhang there is, and then you have an idea of how much material you can take off that corner or that side seal.
And do you put a feeler gauge in there to measure?
Exactly. Yeah. The feeler gauge between your this side seal and this corner seal.
Right.
To get the right clearance, depending on the application.
So you have a spec in mind, or there's a spec in the manual?
Generally, yeah. I mean, for naturally aspirated motors, you obviously want a tighter seal, because you're relying on all the compression from the motor to create the power.
Right.
Whereas on a boosted motor, generally internal temperatures are a lot higher, so these seals could expand more, so you want a little bit looser tolerance.
Right.
I'm sure it's fairly similar with piston engine, piston rings and stuff like that.
All right, last part of the sandwich here. This is the top piece of bread, I guess, eh?
Yeah.
Are we going with a rye today, or maybe just a lightly toasted whole wheat? I guess nothing's lightly toasted with a rotary, is it?
No, you're
Everything's burnt.
well done, cooked. Yeah.
They're not the most fuel efficient engines either, are they, Joe?
No, unfortunately not. I mean, they flow a ton of air, so with air and going into the motor, you need the appropriate amount of fuel, and generally it's a lot.
And emissions and rotaries don't get along that well either, do they?
No, not great either. No, they're not known to be the most efficient at burning the fuel. That's why a lot of the videos you see online of guys shooting fire and flames and all that stuff out the exhaust, which looks cool, but that's just unused fuel.
That's right. That's rotaries hating Mother Earth.
Yeah.
I guess they're a bit like a two-stroke in a sense, aren't they?
Very much so. Yeah, exactly. That's how I describe it to a lot of people, the two-stroke, because of the no camshaft design and just the ports and the way the piston goes past the port is what determines your port timing.
Yeah, and even the brap noise they make is a little two-strokey, isn't it?
Yeah.
Is this our final application of Vaseline, Joe?
This is it.
I'm gonna maybe sound a little emo here, but I'm gonna be sad to see the Vaseline go.
There'll be more motors to build.
It's bringing back a lot of memories of high school and Sears catalogs.
All right.
The underwear section of the Sears catalog, come on, Joe, you know what I'm talking about.
Okay.
Kids with the internet these days are spoiled.
Yeah,
they don't have to use the Sears catalog. So that's it? We're done?
That's it. Well, yeah. For now, we
We've got to bolt this thing together,
next
don't we?
step is we got to bolt it all together, and then we check the end play.
All right, Joe, so these are the big long bolts that hold this whole keg together?
Tension bolts, yeah, that hold the whole thing together. And I remember years and years ago hanging out at Marco Passante's shop, Magnus Motorsport, and he always said, when you're putting head studs in, you always want to lube them, where you get the proper torque.
Okay.
So you always got to lube the threads, get them down in there, and then when you go to torque those down, you're not having any issues with the threads binding and giving you a
all right.
incorrect torque. Oh, geez, good catch.
Joe's juggling.
Yeah.
Is it just motor oil you're using?
Yeah, that's just old motor oil we use for hose assembly or anything. It's
Okay.
10W30.
Mantella spec hose assembly?
Yeah, exactly. Now, these tension bolts, here we go. So, you can probably tell, a lot of these are on the same height,
Yes.
the landings for these.
Yeah.
And now this one's a lot longer.
That one's raised a bit, yeah.
So the top end of this bolt actually has an indentation in it, and
Okay.
that
tells
you
that it
it's
goes
one of the longer ones.
Okay.
So that goes in that location.
Yep. So you kind of do the long ones first just to know you got them in the right place?
No, just whatever I grab.
Whatever you grab, okay.
Whatever I grab out of the pile.
You've done this enough times, I guess, to avoid the rookie mistake of a short bolt in a long hole.
Yeah. This is a short one.
So there's a whole lot of these, and there's, what, 15, 16 of
I think
these?
there's 18, I believe, in total. Yeah, if I remember right.
It's higher than I can count.
Yeah. Me too.
And what's the torque spec on these?
Very low, 30 foot-pounds.
So you don't have to do it in like a stepped sequence or anything?
Yeah, I do. I mean, there's actually a proper sequence according to the factory.
crisscross
Yeah.
pattern, or-
So generally, I start with this one here, which is pretty much dead in the middle.
Yep.
Go to that one, that one, that one. You know, you just
So
kind
like
of
a flywheel bolt
Yep.
type,
Yeah. You just go crisscross
Yep.
all the way across, and you just snug them down one at a time.
So you don't go full 30 foot-pounds on your first.
No, never. No.
You kind of like just hand tighten them,
Yep.
then torque them down to 10 or 15 foot-pounds.
Yep. Exactly.
Gotcha. All right.
Okay.
Let the torquing commence. And Joe was right. We checked the manual just to be safe, but 30 foot-pounds is the spec on these. All right, Joe. So
Okay.
flywheel time.
Yep, tension bolts are all torqued down, and so we'll put the flywheel on. We'll put this this Woodruff key in here in the back of the eccentric shaft, and we'll put our flywheel and counterweight down on. And we'll put this
Interesting.
52 millimeter nut, I believe it is.
52 mil. Wow, I don't have that one in my toolbox.
No, and not a lot of places used to carry large sockets like that when I started building rotaries. So, what I did was I built my own when I was 14 years old.
And you still have it.
When I lived on the farm, this was what you get. This is what you had to work with when you were on the farm. So
Make
yeah,
your own tools, yeah.
there was no such thing as a 52 millimeter socket around the farm. So I took flat stock and just cut them out into pieces, or and laid them around one of the nuts.
Yep.
Welded it to a sprocket, and with the arc welder. That's why they're not
The prettiest?
They're not pretty, but they work. And then I threw an old crummy 1/2-inch drive socket in there and welded that to the socket and or the sprocket, and
16 years later, still going strong.
still going. I won't trade it in for a new snap-on.
That's it.
So we'll just give this a spin over just to make sure we don't have any binding issues since we've just assembled this.
Sounds like there's a parakeet in the engine there.
Yeah. So that's the
Spinning nice and free.
yeah. Seems all right. All right. So we'll
Gun
impact,
that
we'll
puppy
impact
on
that
there?
down, and then we'll move on to the front of the motor.
Okay. All right, so we looked up the torque spec on that big center nut, and it was 360 pound-feet?
360 foot-pounds.
Foot-pounds? And the other flywheel bolts were
45.
45,
for
okay.
these, yeah. And these are I'd use probably blue Loctite on these.
blue Loctite on those, okay.
Yeah.
Cool, so we can put this puppy over.
So there's what That's your rotary engine.
That's your fully assembled Renesis engine.
Yeah.
It's pretty amazingly compact, isn't it? Mm-hmm. But by the time you put the manifold on it and all the other stuff, it gets to be pretty big and heavy, doesn't it?
Mm-hmm. Sure does. So, okay.
So on this side, what goes in here?
So we've got some Torrington bearings and a plate and spacers and some gears that drive the oil pump and the oil metering pump, and then the crank pulley, and then we torque that down, and then we check the end play to make sure it's within spec. First is this thrust washer.
Yep.
Goes down on the top of the crank. One of our Torrington bearings. I'll put the spacer down. So these spacers are actually marked, if you can see that. That's a D spacer.
Okay.
It goes from A all the way down to EF, I believe, or something like that.
Okay.
And they're all different thicknesses.
Yep.
And this determines the end play of the engine.
Okay. And we're reusing that because this should still all be to the same spec as it was prior to.
It should be, yeah. But obviously we're gonna
Check the
stack it
plans,
together, and we'll check it. And if we need to make an adjustment, we will.
Right.
So okay. Now we can torque that front stationary gear down.
All right, more torquing, this time 17 foot-pounds. Not 16, not 18, people. 17. All right, counterbalance weight in place.
There we go.
Joe's just randomly dropping things on here now.
Yeah.
He doesn't even know what these things are for. Just slamming them on there. Look at those fancy looking gears. What do those do, Joe?
So the chain-driven one is actually for the oil pump, which sits here.
Yeah.
We're just going to assemble this just to get our end play.
Mm-hmm.
And this helical cut gear actually runs the oil metering pump.
Oil metering pump, right.
It's to the front cover.
The OMP.
OMP.
Rotary guys will know what we're talking about. Everyone else will be like, huh? It squirts a bit of oil into the combustion chambers, right?
Yes, correct.
And that's to kind of keep the apex seals lubricated and not peeling themselves off on the housings.
Exactly.
Something like that.
Exactly. So we'll torque this down.
So this was all put together so we could check the end play on the E-shaft. There will be stuff in there later. All right, Joe, show us how you check the end play here.
All right, so we assemble the front stack, and we torque the crank bolt to 100 foot-pounds, so we set up our magnetic-based dial gauge here. I always set it up on the landing for the oil pump because it's a nice flat, true surface.
Yeah.
And of course, we're using the best of the best equipment here, Power Fist.
Yeah, only the best. Princess Auto.
Exactly. So anyway, I've got this set up here, and it's showing. Well, I've got the dial gauge right now at like 21, and if I lift up on this rear plate and push down, that shows me just over 23. Just over 23. So we're about 2.1 thou end play, I would say.
Okay.
And
is that within spec?
Yeah, the book calls for anywhere from 1.6 or 16 thou, I guess, to 3.5 or 35 thou.
Okay.
So we're at
22 or something.
21, 22. Yeah.
So
yeah.
we're well within spec.
Oh yeah, well within spec, right in the middle. So I'm pretty happy with that.
Cool.
So we'll disassemble this front stack again, and we'll put
all the goodies in there.
Yeah, put the oil pump back on the chain, and then the front cover can go on, and then this can go on at last and torque down, and we've got ourselves a short block.
Joe's on the phone with his wife.
All right.
He's using his husband voice.
All right, love you too. Bye.
I got to love you too and everything. Sweet. Okay. All right, what do we got there, Joe?
All right, so this is the oil pump and the chain that drives it.
Yep.
Now, I've seen a ton of engines that come to me with this oil pump completely disassembled. They knock this washer back, take the nut off, the pulley comes off, and there's a little Woodruff key in there, and it is the biggest pain in the ass to reassemble.
Okay.
So I never take these things apart.
Okay.
I always just take, there's 4 little M6 bolts that hold this to the front iron here.
Yeah.
And more than enough room to access it with a wrench, a box end wrench,
Okay.
to undo them and put the bolts back in. So
don't take these apart,
don't
people.
take these apart. And if I do get an engine from you that has this apart, I'll make you reassemble it yourself. So we'll put these 2 together, mesh these up, and we'll start that on there and drop this here. There we go.
So fancy.
Installing these bolts is quite easy, even with that pulley on. Get that started.
Yeah. But Joe, how do you fit a torque wrench in there?
Well, I knew you were going to say that. And I knew probably someone on the internet will probably say the same thing.
Yeah.
That's not, you won't be able to properly torque that with the pulley on. Well, you're right. You can't actually fit a torque wrench in here to torque these. But with experienced hands like myself, you can, it's just a regular M6 bolt. There's nothing special about it. So tighten by feel.
Good and tight, as we say. Mm-hmm. All right, I can live with that. It worked before the 10,500 RPM, so I don't think it's going to be a problem.
Yeah, exactly.
All right, brand new front cover gasket.
Front cover gasket.
What is that, a metal gasket?
It is a metal
It does look
gasket.
like a metal gasket. It looks very fancy.
Mm-hmm. Probably expensive. I don't remember.
Yeah, it probably is expensive. Glad somebody else is paying this time.
All right, there we are, and our front cover.
Yeah.
So there is your drive that corresponds with this
helical gear.
helical gear.
Yep.
And that actually goes to the outside here, and that drives your oil metering pump, which bolts onto here.
Okay, that's your little engine oil squirter deal.
Exactly.
Cool.
So we'll slide this down, line up these studs, and onto the dowels.
Man, everything is just cooperating so well.
Look at that.
Look at that, everybody.
And then we'll put the crank pulley back on.
With the crank pulley on there, we will have a fully assembled Renesis engine.
Oh, just about forgot that. Okay.
And just like that,
Good. We're missing a few bolts here. We'll bolt those down, but just like that, that assembly's all together. And
that was too easy, Joe. I think that deserves a high five from you.
Yeah.
Nice work.
yes.
If you're more into carbon fiber race cars than you are rotary engines, then Mantella Autosport's got you covered for that too. This is a KTM Xbow GT4 car. They run 2 of these in the Pirelli World Challenge GTS class, and this one is for sale. And man, if I had $250,000 burning a hole in my pocket, yes please. Race cars just chilling over here. Crazy looking machines. I sat in this one and felt like an astronaut in a good way.